Hello everyone, in computer system organization today we are going to talk about the memory unit, and precisely we will be talking about the primary memory, or which is also called the main memory. By definition, memory unit or primary or main memory is used as a storage unit for instructions or programs as well as the data inside the computer, and memory unit is directly accessed by the CPU of a computer. If we want to understand the composition of a memory unit, it is composed of cells, and each cell is further broken down into smaller components called bits. From here we can see that this blue block is called a cell named cell 0. Similarly, we can have cell 1, cell 2 up to cell n, and each cell is further broken down into smaller units called bits. Either it can be 1 or 0, as we know that a binary language is the language which can be understood by the computer only. So each 1 or each 0 is called a bit, and collection of 8 bits or a group of 8 bits is called 1 byte, which is here. So in case actually it is the main measurement unit which we use for measuring the computer memory. And a collection of 4 bits is also called 1 nibble, but it's not normally used in the measurement. So now we'll categorize memory unit. Memory unit can be categorized as RAM or ROM. So RAM is random access memory and ROM is read-only memory. First we understand the RAM. RAM is both read as well as write type of memory. We can read from it, we can write on it. RAM is used for primary storage in the computer to hold the active information of the data and instruction, which means it actually stores the data and instructions associated with the application or the software which is currently being used in the computer system. Whatever application, whatever software is running on the computer, all the associated data and instructions are stored in the RAM. And RAM is volatile memory, which means if the electricity or the power is switched off or interrupted, the content of RAM is lost. So talk about types of RAM. First of all, we'll understand one concept, that is memory access time. The amount of time taken to produce or fetch the data from the memory from the start of access until the availability of the data. So actually is called memory access time. So more the memory access time means the slower is memory, and lesser is the memory access time means faster is the memory. So RAM can be categorized into 2 types of RAM, like dynamic RAM and static RAM. The DRAM is made up of transistor and capacitor, whereas the static RAM is made up of flip-flops. So the electronic composition is different, and memory access time of dynamic RAM is 20 to 70 nanosecond. It's a range, and that is for the static RAM it's only 10 seconds. So we can see that SRAM is much faster than DRAM. So the DRAM is primarily used for the storage section of the computer, whereas SRAM is used for specialized application where we need faster processing. Now we talk about the ROM. ROM is actually read-only memory, which means the data and instructions are permanently stored in the ROM at the time of manufacturing, which cannot be changed. And ROM is non-volatile, means if electricity or the power goes off, the data and the instruction stored in the ROM will remain as it is, no change. And it is obviously slower than ROM. We can see a picture of ROM here. Now we'll talk about the type of ROM. This is programmable read-only memory, erasable programmable read-only memory, electrically erasable programmable read-only memory, flash EEPROM, and mask ROM. We'll understand them. Now PROM, it is one-time programmable by the users. With the help of ROM burner, we can actually burn the information in the ROM. Next is EEPROM, which is in which the information can be erased, and which is fully erased, and the memory can be reprogrammed as many as time we want, and the ultraviolet rays are used to erase the information, but it takes a lot of time, like 20 minutes for one full erase. But in case of the EEPROM, the same process of erasing the content in the memory takes place with the help of electricity instead of ultraviolet rays. It takes comparatively very less time, but also we can erase selective bytes rather than whole memory. So in flash EEPROM, it can erase the whole memory at a time, but it is comparatively faster in the sense less than 1 second it takes, like. So the last one is your mask ROM. Mask ROM is actually programmed by the manufacturer at the time of manufacturing, not by the user. So now talk about the units of memory, and the basic unit is still the binary digit, that is 1 or a 0, which is called a 1 bit, as we have already discussed. But the fundamental unit which still considered like byte is used for this, which is a collection of 8 bits, and 1 kilobyte is equal to 1024 bytes. Now we can sometimes confuse with it, like 1 kilo means 1000. So it's not the case. 1000 is used when we use the decimal number system, that is in mathematics, where the base of the number system is 10. We use 0 to 9, 10 numbers to express any physical quantity. But in the binary format, the binary algebra, or the Boolean algebra basically, we use only 2 digits, 0 or 1, which means the base of this whole algebra is 2. So anything which will be the unit of memory will be expressed in the power of 2. So like 2 raised to the power 4, 2 raised to the power 3 is 8 actually. So 2 raised to the power 4, 16, 2 raised to the power 5, 32. You have seen like the memory cards are like 32-bit, 64 GB, like 64 after 128, 256. All the denominations of these units are actually the powers of 2. In the similar manner, like 2 raised to the power 10, which is 1024, is actually 1 kilo. So 1 megabyte is 1024 kilobyte, 1 GB is 1024 MB, similarly 1 TB is 1024 GBs, and it goes on from petabyte, exabyte, zettabyte, yottabyte, brontobyte, and zeobyte, like that. As per the data angry generation, we are getting more and more ahead and down the ladder. So now we'll talk about an important type of memory, which is cache memory. Cache memory is the memory which is placed between the CPU and the main memory, and it makes the data available to the CPU very quickly by sending the data to the CPU instead of main memory, and thus reduces the access time and efficiency. Also increases the overall performance of the computer system, also increases. You can see in this diagram also the L cache, L1 cache, L2 cache, and L3 cache. Cache memory is the memory which can be is a small memory which can be present within the CPU or on the motherboard, out just near the CPU, or on the bus also, but well before the main memory. So it provides that data or the instruction very fast to the CPU so that it can function in a faster manner. So the cache memory is integrated directly within the CPU chip or placed as a separate chip that has a separate bus interconnected to the CPU. It's a small memory, work faster than the primary memory, that is RAM. So for this whole content, you can refer these 2 books, and feel free to ask any question. Thank you.